Welcome to the lecture on classification, Counting the Cost, Part 2.
Part of the material presented in this lecture is taken from the following book, while transcription and interpretation errors are responsibility of the lecturer.
In this lecture, the following concepts will be introduced: cumulative gains and lift factor. In the last lecture, you learned from your friend that when solving a binary classification problem, in the case where the cost of the two errors is not the same, so we are in presence of asymmetric costs, then learning a classification model by maximizing the accuracy may not be the first option. Indeed, in that case, we typically prefer to learn a classifier which minimizes the expected cost of the classification. However, you can question your friend because in practice, costs are rarely known with any degree of accuracy, and it is known that it is always better to ponder various different scenarios. Your friend reminds you that promotional action of the telecom company can be offered to no more than 500 customers, which must be then carefully selected in such a way that most of them are churners. So you are in the following situation. Assume you have 1,334 customers and your problem is to select a subset of these customers, in particular a subset consisting of 500 customers, in such a way that the number of churners that it is included in this subset is maximized. To help to solve this problem, your friend tells you that based on the experience accumulated through previous promotional actions, the churners are estimated to be around 15% of the customers. So in our case, if we consider a number of customers which is equal to 1,334, we will have 1,334 times 0.15, so 15%, which brings us to obtain 200 churners out of 1,334 customers, while in the sample of potential churners, which consists of 500 customers, we expect that 500 times 0.15, so 75 churners will be included out of the 500 potential churners. Then we will have the following situation. If this sample, the sample of potential churners, have been obtained by applying a random sampling from the customer set, then we would expect the following situation to occur. We have that 75 churners will be included into the potential churner subset, which will also contain 425 known churners, while the remaining 125 churners will be included into the customer subset, which has not been sampled to be the potential churners. Finally, we will have that 709 customers, so in particular non-churners, will remain the customer set. So to summarize, if we apply random sampling, so if these 500 potential churners are randomly selected among the 1,334 customers, we would expect that around 37.5% of the true churners will be correctly identified, and this is the result of dividing 75, so the number of churners included into the potential churner subset, divided by 125 plus 75, so divided by 200, which is the number of churners included into the customers dataset, so the total number of churners that we want to identify. Your friend also tells you that the proportion of churners which is known to be correctly mailed using the standard mail-out procedure is equal to 50%. So this means that out of the 200 churners which are included into the customer set, you will obtain that 200 times 0.5, so 100 churners will be correctly included into the potential churner subset. In other terms, if we apply the standard mail-out procedure of the telecom company, we will have the following situation. 100 of churners will be correctly included into the subset of potential churners, and the 400 non-churners will be included into the potential churner subset, while the remaining 100 churners will remain the customer set, and so they will not be included into the potential churner subset, while 734 non-churners will remain the customer set. So in this case, then, if we apply the standard mail-out procedure, we would expect to correctly identify 50% of the churners, and this is the results of dividing the number of churners which are included into the potential churner subset, which is equal to 100, divided by the total number of churners of the customer set, which is equal to 100 plus 100, so 200. However, you develop a classification model capital M that when applied to the set of customers, so to the set consisting of 1,334 customers, selects a subset of 500 potential churners, so this subset, such that 60% of the churners are correctly identified. So because of the fact we know that the number of churners is equal to 200, then 200 multiplied by 0.6, 60%, will give 120 churners to be correctly identified when we apply the classification model to the customer set consisting of 1,334 customers. So in other terms, if you apply the classification model capital M to the customer set, the set consisting of 1,334 customers, then you will end up with this confusion matrix, where 120 churners are correctly included into the potential churner subset, which also contains 380 known churners, while the remaining 80 churners are not included into the potential churner subset. Then, to summarize, we have the following situation. If you apply the classification model capital M, then you will be able to correctly identify 60% of the churners. So you will include 120 churners into the potential churner subset, and 60% is the result of 120 correctly identified churners, so included into the potential churner subset, divided by the total number of churners, which is equal to 80, so the number of churners not included into the potential churner subset, plus the number of churners which are indeed included into the potential churner set. Then we have the following. If the set of potential churners consisting of 500 individuals is selected from the set of customers of 1,334 customers by using a random sampling, you expect that 37.5% of the churners will be correctly identified and so included into the potential churner subset. While if you apply the standard mail-out procedure, you expect this percentage to rise up to 50%. And finally, if you apply your classification model capital M, you will still improve from 50% to 60%. Then it may well pay off to restrict the mail-out of these 500 customers. That depends on the mailing cost compared to the return gain for each response to the promotion. Well, your friends now tells you that in marketing terminology, the increase in response rate, a factor of 1.6 in this case, rising from 37.5% achieved by applying the random sampling up to 60%, which is achieved by applying the classification model you have developed, is known as the lift factor yielded by the classification model capital M with respect to the random sampling procedure. Your friend also tells you that knowing the cost will result in determining the payoff implied by a particular lift factor. However, changing the parameter setting of the classification model capital M can result in identifying different customers. To better clarify this aspect, let us take into account the following situation. You have the set of customers, 1334 customers, and applying to this set of customers your classification model capital 1, this classification model selects a subset of 500 potential churners from the set of 1334 customers. And this model, is capable to correctly identify 60% of the churners. So in other terms, it is capable to correctly identify 120 churners out of the 200 churners that are included into the customer set consisting of 1334 customers. However, if you apply a different classification model, the classification model capital M2, then this model will select a subset now consisting of just 200 customers as potential churners. No 500 like the first model, like classification model M1, but just 200 customers are selected as the potential churners. You also know that this model is such that exactly 40% of the churners are correctly identified. So in this case, by using the classification model capital M2, you will be capable to correctly identify 8 churners out of the 200 churners that are included into the customer set. Accordingly to what we have just introduced and commented, you are in the following situation. If you apply the classification model capital M1, then you will select a subset of 500 customers, while if you apply the classification model capital M2, you will select a subset consisting of 200 customers, and in particular, these two subsets will include different customers. Therefore, you are left with the following question. Which is the most profitable target for the mailout? To answer the previous question, you need to know profitability of each mail-out procedure. However, you know that profitability can be computed only once you know the costs involved. Therefore, when you don't know the cost, you must resort to other procedures to compare different classification models, and this is exactly what we are gonna presenting in the next slides. Well, we are now in the condition to introduce cumulative gains. Given a classification model capital M, which outputs the predicted probabilities for the positive class, you must find subsets of the customer sets that have the following property. This subset must contain high proportion of positive records and in particular higher than in the customer set. To better clarify this aspect, let us proceed as follows. Assume that the set of customers consists of just 10 individuals, so just 10 customers. Furthermore, assume that you apply the classification model capital M to these 10 records, 10 customers, and get the probability value according to classification model capital M that each of these 10 customers is a churner. So in other terms, you apply the classification model capital M to the 10 individuals, to the 10 customers, and you get the probability that each one of them is a churner. So probability of churner equal to yes. Then you have the following table. You have the row ID and the associated value of the probability that the corresponding customer is a churner. For example, the customer with identifier 67 has a probability equal to 0.47 of being a customer, and this according to what computed by the classification model capital M. The second step you apply is to sort the customer records of the customer set in descending order of the probability prob y, so the probability estimated by the classification model capital M that each of these customer is a churner. So you move from this situation of your table to the following situation, where you can see that the first element of this list is associated with a probability of being a churner, which is greater than the second one, and this probability, the probability that the second customer is a churner, is greater than the probability that the third customer is a churner, and so on. You then find a subset of a given size, for example 3, with the greatest possible proportion of positive records. You just read the requisite number of the records of the list starting at the top. So you get this table and you read the first 3 records to obtain the following subset selection. So in this case, we have that we selected the first 3 customers of this list as being the churners, so those people that will be included into the set of potential customers. Then you go to compute the lift factor of this sample selection. However, to compute the lift factor associated with the subset selection consisting of 3 customers, you need to compute how many churners the classification model capital M will identify when used to select 3 customers. And for this reason, you need an additional column, the column of the churn, so of the class attribute, which is reported here as the last column. Now you can compute the lift associated with this subset selection obtained by applying the classification model capital M to the customer set consisting of 10 records. In particular, in this subset consisting of 3 records, you have that 2 of these records are indeed churners, while the third one is not a churner. Then, in the subset consisting of 3 records, so this subset, the subset of potential churners, you are capable to correctly identify 2 records out of 3 of the positive one, which are included into the customer set consisting of 10 customers. Indeed, we have 1, 2, 3 positive, so 3 churners in the dataset consisting of 10 customers. So if we apply the classification model capital M to select the first 3 customers as the potential churners, we correctly identify 2 of the 3 that are included into the 10 customers dataset. So in this case, we have then that 2 out of 3, so 0.66, is the fraction of positive records which are correctly identified by the procedure which selects the first 3 customers according to the probability computed by the classification model capital M. Then we conclude that the lift in this case is equal to 0.66 divided by 0.3, and so it is equal to 2.22. However, we need to better clarify how the lift value is computed. In particular, we have just shown that the lift value associated with the subset of potential churners consisting of 3 customers selected by using the probability values computed by the classification model capital M applied to the customer set consisting of 10 customers was equal to 0.6 divided by 0.3. But while the meaning of the term 0.6 is clear, indeed it simply represents the fraction of positive records or the fraction of churners which are correctly identified when using the classification model to select this subset of potential churners. Indeed, we have that exactly 2 out of the 3 are correctly identified. The meaning of the term 0.3 is not clear. So what's the meaning of 0.3 here? Then the meaning of 0.3 is readily explained. Indeed, it is simply the expected fraction of churners which are correctly identified if we select a random sample consisting of 3 customers selected from the set of the 10 customers using the random sampling procedure. So in other terms, if out of these 10 customers we form using a random sampling a sample of potential churners consisting of 3 customers, then we would expect, because of the fact this sample consists of 3 elements, which is 30% of the total amount of the customers, we would expect that if the selection is random, then exactly 30% of the churners will be correctly identified. In particular, in this case, we would expect that nearly 1, so in particular 0.9 churners will be correctly identified. Therefore, in conclusion, 0.3 is obtained as 3 divided by 10. 3 is the cardinality of the potential subset, while 10 is the cardinality of the customer set. And it is the fraction of churners which are correctly identified when the random sampling procedure is applied to this customer set and the proportion of this sample is equal to 30%. To better clarify the concept of lift and to stress that the lift achieved by a classification model depends on the dimension or the cardinality of the subset of potential churners or potential customer which is selected, we now take into consideration the situation where the probability values computed by the classification model capital M are used to select a subset of potential churners which consist of 5 customers. In this case, as well as you can see, including the rank 4 and 5 observation, we include non-churners customers. So in particular, in a subset consisting of 5 records, we obtain the following: that still 2 records out of the 3 positives are correctly identified. In other terms, we have that 2 divided by 3, so 0.66, is the fraction of positive records that are correctly identified as such by this new subset of potential customers. Then the value of the lift associated with this new subset of potential customers is equal to 0.66, the fraction of positive records, so the fraction of churners which are correctly identified, divided by 0.5. Indeed, 0.5 is the fraction of positive records which is correctly identified by applying the random sampling procedure. Indeed, this sample, 1, 2, 3, 4, 5, is the 50% of the entire set of the customer set. So by sampling 50% of the records, we would expect that if the sample is random, exactly 50% of the churners will be correctly selected. So in this case, the lift of this procedure is now equal to 0.66 divided by 0.5, which is equal to 1.33, which is smaller than 2.22, which was associated with the selection of just 3 potential customers. We will see more about these relationships of the lift value for each classifier when selecting an increasing number of customers. We will see further in the next slides.
A graphical representation of the empirical procedure just shown, which allows to have a depiction of the various possibilities, will be far more revealing than presenting a single optimal decision. We then now introduce the cumulative gains diagrams. The x-axis of this diagram is associated with the percentage of subset size, so it is the ratio of the cardinality of the selected subset to the cardinality of the original set. In particular, if we have the original set consisting of 1,000 customers, then we will have that 10% will be equal to 100, 20% will be equal to 200, and so on. The y-axis is instead associated with the percentage of positive recurs. And to clarify its meaning, we simply assume, for example, that out of 1,000 customers of the original set, we have that 200 are positive recurs. Then in this case we will have then 10% of 200 will be 20, 20% will be equal to 40, and so on. So to conclude, the y-axis represents the percentage of positive recurs computed on the overall set of positive recurs. The cumulative gains diagram is associated with different lines. In particular, here we have the green one, so the diagonal line, which is associated with the no model or zero error classification rule. This rule simply selects the customer to be added to the subset by using the a priori rule. So it samples recurs as belonging to the positive class according to the proportion of individuals that are positive in the original set. The red line is instead associated with the classification model that we want to evaluate and compare using the cumulative gains diagram. Let us now show how to use the cumulative gains diagram. First of all, you select a given number of customers to mail out. For example, you select 1,000 of customers. Assume that the 1,000 customers you have selected, so the 1,000 customers belonging to this subset of customers, correspond to the 10% of the customer set, so to the 10% of the cardinality of the customer set. Then you go to the cumulative gains diagram, in particular to the x-axis, and you select the 10% value. Then you intersect the red line, so the line associated with the classification model, to compute which is the associated percentage of positive recurs, which is equal to 38%. On the contrary, if you select 3,000 customers to belong to the customer subset, then it corresponds to the 30% of the customer set. Then you go to the cumulative gains diagram and you select on the x-axis the value 30. Then you intersect the line associated with the classification model to compute which is the percentage of positive recurs associated with it, that in this case is equal to 72%.